Warm greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed on the latitudinal heat balance. In this lecture, we will be discussing about horizontal temperature distribution. What are the various contents we are going to discuss in this lecture? That is the concept of horizontal temperature distribution, what are all the factors which determines or affect the temperature distribution, the temperature distribution where the data sources are collected, in what method the data sources are collected, and the importance of horizontal temperature distribution studies. The concept of horizontal temperature distribution, the study of distribution of temperature is attempted in several ways, that is the temporal distribution and spatial distribution. So, what is meant by temporal distribution? The distribution is analyzed or studied based on the years. For example, if it is going to be a 2000 year temperature is going to be studied or compared with the 2010 temperature of the spatial distribution is known as temporal. Temporal means time distribution of temperature. And then spatial distribution, that is over space how the temperature have been distributed. So, that is known as the spatial distribution. Always geographers will be focused on what? The spatial distribution along with the temporal distribution. So, here we will be discussing more on spatial distribution. It is also known as regional distribution. Spatial distribution is also known as regional distribution of temperature. The spatial distribution have been studied in two ways. What are all the ways? That is vertical distribution of temperature and horizontal distribution of temperature. Today in this lecture we will be discussing on horizontal distribution of temperature. In the next lecture we will be concentrating on the vertical distribution of temperature. What is the concept of horizontal temperature distribution? That is the distribution of temperature across the different locations. So, whatever the location may be, what is the distribution of temperature? So, that is concentrated in this horizontal temperature distribution. The focus on variation at the same altitude. So, if it is going to be same altitude, for example, if it is altitude means not only the height, if it is going to be a mean sea level above 20 or 30, the same latitudinal extension have different what temperature. The temperature differences form the patterns across the continent and oceans. Ocean and continent have the same temperature? No, it varies. So, that difference have been witnessed in the horizontal temperature distribution. The horizontal gradients affect what? The wind circulation. So, wind movement is also affected by this horizontal gradient, and on the basis of this weather, climate, vegetation zones are classified, and animals and human life distribution are based on this horizontal temperature distribution. What are all the factors affecting the temperature distribution? They are latitudes or distance from equator, continentality with maritime influence, altitude, nature of land and water, land surface characteristics, prevailing winds, ocean currents and cloud cover. So, these are all the major factors which affects the temperature distribution of that particular locality. Latitude as a primary control. So, often we discuss this one, that is the solar angle. So, decreases where? Decreases, the solar angle decreases with the latitudes, and the insolation which is received in the equator region will be highest and the polar region will be lowest. It creates what? Major temperature zone. The temperature zones have been classified based on the solar radiation receivance, and it also causes the latitudinal temperature gradient. So, the major factor is latitude. The next one is equatorial temperature characteristics. So, equator, the region which receives the most effective incoming solar radiation, the temperature will be high throughout the year and annual temperature range will be very small compared to the higher latitudes. The intense heating will be there, it will be very strong, which forms what? The conventional uplift. that is warm air rises due to the conventional process. The region dominates with persistent low pressure belt, that we all know that here what belt is present, intertropical convergence zone is present here. So, because of that there will be a permanent what low pressure belt will be experienced in this latitude. The warm ocean current water supplies abundant moisture and energy in this region, in this latitude. Mid-latitude temperature characteristics, how the temperature will be there in the mid-latitude, it won't be that much harsh or that much hot at equatorial region. So, it is a moderate, it is generally moderate throughout the year. The climate shows the distinct seasonality. The seasons will be there in the mid-latitudes, and the annual temperature range will be larger than tropics. Tropics it's minimum, here it's a larger. The prevailing westerlies is strong influence in the weather condition. So, in this zone only we can find the westerly wind. So, the climate varies between the continental interiors and then the maritime region, that is ocean, the coastal regions. A polar temperature characteristics, how the polar region will be there, that is the temperature remains very low for the most of the year. So, the low temperature is experienced. Because of low temperature there is extensive ice and snow which creates what? High albedo. Albedo effect high will be there in this polar region, which is reflecting the solar radiation that is which reflects high solar radiation. The solar insolation is weak due to the angle of the sun. The sun's angle is oblique in this region, that is in this polar latitudes. The climate shows a large seasonal contrast. The contrastivity will be there in this polar region, and winters are extremely cold and prolonged winters will be experienced in the polar latitudes. Land and water contrast, so this we have discussed often, that is land heats and cool very fast, and then the air which is near the surface will be denser, and if it is going to be a higher altitudes the air will be lighter. The ocean have the moderate temperature and it reduces the extremes. The moderate climate will be prevailed in the coastal region, the extremity will be avoided in the coastal regions. The continental interior experiences the extreme temperature because it is far away from the water bodies, that is far away from the sea. The heat transfer occurs through how the heat is transferred. There should be some medium, that is what is the medium? The radiation, conduction and convection. So, these are all the process by which the heat is transferred from both land and water surfaces. Continentality, it's a inland areas have a high temperature range. So, interior have the high temperature range, and the land, why this high temperature prevails in the interior? Because of the land and sea breeze. So, the wind which blows from land breeze, it is also known as offshore wind, and the wind which blows from the sea is known as sea breeze, it is also known as onshore wind. It's extremely high it have extremely high daily range of temperature in the continental climates. So, it is a contrastivity, it tries to heat and cool. So, that contrastivity creates what? High daily range of temperature. The hot summers and cold winter will be there in the interior of the continents, and it enhances the horizontal contrast. So, the contrastivity will varies in the horizontal latitudes. Maritime influence, that is the coastal influence, water bodies influence. The coastal areas, how the temperature will be there, it have the moderate effect and it have the moderate weather condition. So, minimum daily range of temperature will be there in maritime influence, that is the coastal region. It have the marine climate. So, the coastal region have the marine climate. It have the cool summers and mild winter. So, the coastal region mainly experience cool summer and mild winters. The stable climates near the coastal regions. The coastal region have the stable climate, and you can see that there is a smooth gradients can be seen in the maritime influence. Continental was a coastal region. So, we have discussed in the previous slides that what is meant by continentality, what is meant by maritime effect. So, here what is the comparison, that is the coastal region experiences the mild and equable temperature, and continental interiors shows the extreme temperature. So, in the picture you can see the Europe and Siberia. See, here you can see the moderate effect and here the extreme cold. So, in the same latitudes you can see these, in the latitudinal difference you can see the variations. The land and sea contrast is the strongest during northern hemisphere winter. The Europe remains milder while compared to the extreme cold Siberia. The seasonal changes makes the horizontal temperature pattern more distinct. So, the season also plays an important role in the continental as well as in the coastal regions. Sea surface temperature, in short we call it as SST. The sea surface temperature is strongly influenced by what? The atmospheric temperature. The warm sea, what happens? It enhances the evaporation. If the seas are heated up, automatically the evaporation process will be happening in that particular region, and it also enhances the warming and moistening air in that particular region. The cold seas produces what? Stable, cooler air condition. Stable, cooler air condition will be there in the cold seas. The sea surface temperature plays an important role in the cyclone process, that is cyclone development and intensity. The variations in sea surface temperature drives regional climatic differences. Because of this variation, there is a difference in regional climate. So, it plays an important role. Nature of land and waters. What is the nature? If the nature of the land is contrasting heat behavior, that is, the land, we all know that it won't allow the heat more than 1 meter, but if while comparing to the land, the ocean allows the heat to several meters in depth. So, because of that, the land is opaque in nature, which heat is concentrated at the surface. So, here itself it restricts, it won't allow this heat inside the land, but here in the water it allows the heat inside. So, it is transparent. So, due to the transparency, the heat is penetrated inside into deeper water bodies, that is ocean. The land redistributes the heat slowly. So, even though it attracts, it redistributes very slow. Water redistribute very quick. Conduction process in the land is very slow compared to the condensation process in the water. It condenses very well. The high ocean evaporation uses heat and lowering the surface temperature. So, in such a way, the nature of land and water is most important factor. Nature of slope. So, nature of slope, that is sun facing slope, receives more insolation because it is near vertical rays. It receives what? Vertical rays. So, the sun facing slope have receiving the more sun rays. The slope facing away, the that is far away region will be receiving somewhat less insolation. These slopes, that is east west mountain ranges and south facing slopes, get more insolation in the both the hemisphere. The example is that the longer sun is exposed mainly in which slope, that is south facing slope. It makes the south facing slopes warmer. In due course, what happens? It supports the settlements and cultivation in the southern slope. Example, Alps and the Himalayas. Wind and horizontal temperature. So, how the wind and horizontal temperature supports it? The wind transport warm and cold air between regions, that is by the support of land and sea breeze and prevailing winds. So, these are all the process which transport the warm and cold air. It also reduces the temperature contrast between areas. So, one area is different from other region because of this land and sea breeze and prevailing winds. The westerlies mix the air masses in the mid-latitude. So, it is a mixing zone and it moderates the climate. The trade wind which regulate the temperature in the tropical region. See, in each and every zones how the wind plays a vital role. The westerlies in the mid latitudes and trade wind in the tropical region, and monsoon wind cause the seasonal heating and cooling pattern. So, in such a way each and every wind plays its dominant role in various processes. Pressure and temperature relationship, that is the warm air rises and create low pressure. So, warm air always it is very less dense, due to that what happens? It rises, and in contrast the cold air will be more dense and it sinks. So, this major rise and sinks, what happens because of the pressure difference controls in the direction and speed of the wind. Because of that the direction and speed of the wind is controlled. The horizontal temperature contrast forms global pressure belts. So, horizontal temperature contrast leads to global pressure belts. These pressure belts drive large scale atmospheric circulation. So, all these wind circulation, global pressure belts are created because of this warm and cold air process, either sinking and rising. All these process leads to this major phenomena in global level. So, air mass influence. What is meant by air mass? Air mass is the large bodies of air which have the uniform temperature and humidity. So, group of one big bundle of air have the same characteristics, that is the air mass. It have a major types are there, that is the tropical air mass, polar air mass, continental air mass and maritime air mass. So, these are all the types of air masses. Air masses movement creates horizontal temperature difference. Due to this movement there is a horizontally the temperature will differ. The boundaries between the air masses, can you recollect it? What is that boundary between warm air and cold air? The boundary is termed as fronts. So, okay, the fronts, the boundary region are responsible for what? The frontal weather system. So, front is responsible for frontal weather system. So, the weather the air masses influences the local weather and the climate of that particular region. Next factor is ocean current. The warm ocean current from the tropics is rising the temperature of the temperate and cold region. So, what happened? So, here you have the warm temperature, that is warm ocean current, which will be rising and moving there in the polar region, and the cold ocean current will be travelling towards the equator region, that is lower latitude. So, because of this exchange or transfer of this warm ocean current and cold ocean current, there is a major differences in the rise and fall of the temperature. The Gulf Stream warms the northwestern Europe. So, the Gulf Stream, because of the Gulf Stream the northwestern Europe is warmed, and Kuroshio warms the Japan. Japan is warmed by the Kuroshio current, and cold currents from that is a Labrador and then Peru and California. So, this in turn lowers the coastal temperature. So, because of this cold current it lowers the coastal temperature of the coastal region. The ocean currents helps to redistribute the heat and equalize the global temperature. See how importantly these ocean currents are playing the transfer of heat, that is the temperature from one latitude towards the other latitudes. Cloud cover. The cloud cover influences local, daily and seasonal temperature. That is a clear sky which allows the incoming solar radiation. So, because of that what happens? The rapid heat loss will be there, and because of rapid heat loss from the surface will be colder. The colder nights will be prevailing in the clear sky days, and if there is a cloudy days, comparatively the clouds will hold the temperature and it won't allow to escape to the upper atmosphere. So, what happens in the night times, comparatively it will be warmer. So, that contrast in temperature will be the effect of the cloud cover. So, the next one is the isotherm. What is meant by isotherm? Isotherms are the imaginary lines which joins the places with equal temperature. So, it is an imaginary line we are going to draw where the places having the equal same temperature. For example, here you have the 30 degree Celsius. So, 30 degree, so this place also have the 30 degree Celsius here, 30 degree Celsius here, 30 degree Celsius. So, what we are going to do? We are going to connect these 30 degrees Celsius. So, this line is known as isotherm. See here you can see the 40 degree isotherm line, and for example 20 degree isotherm line. So, like that you have the isotherm line. They represent the horizontal distribution of temperature. What is the use of it? It plays a vital role in the map that it shows the horizontal distribution. So, you can see what is the distribution of temperature here and how it varies in this part and how it varies in this part. So, this variation can be seen in the map with the help of isotherms. It helps reveals the temperature pattern, gradient and anomalies. So, all these can be detected with the help of isotherms. It is useful for regional global temperature comparison and interpretation. So, because of this isotherm, the interpretation can be done globally and the temperature can be compared from one place to another place. So, in such a way this isotherm is very much helpful. January temperature pattern. So, in January how the temperature will be there? In the northern hemisphere becomes a colder during winter, and a strong cooling occurs over a large continental interiors. So, in this map you can see the isotherm line. So, the bend is towards what? It is towards the equator word. So, it is the bend is towards the equator. The isotherm bend equatorward over the land due to intense cooling. So, why this bend is there towards the equator? It is because of cooling. It wants to cool itself. So, because of that its bend is towards the equator side, and the ocean retain heat and remains comparatively warmer. So, the ocean area will be warm in the January temperature pattern, and westerly winds influence the distribution of temperature and isotherm. So, in this January temperature, the westerly wind plays a vital role which is influencing the distribution of temperature as well as the isotherms. Next one is July temperature. See the contrast. In the January it was bend is towards the equator side. Here you can see the bend is towards the polar side, polar region. The bend will be towards the polar region. So, in the northern hemisphere becomes a warm during summer. The isotherm shift poleward due to increased heating. There for cooling it was bent towards the equator. Here in the July temperature it is bending towards the polar region due to increased heating. The extensive land masses heat up strongly in July, and the monsoon circulation modifies the temperature pattern of Asia. You know that it is a monsoonal region. So, because of that the monsoon circulation pattern modifies the Asiatic region, and the southern hemisphere it remains comparatively cooler. So, there we saw about the water mass, the water bodies. Here the southern hemisphere remains comparatively cooler in the July temperature pattern. Annual temperature range pattern. Annually how the temperature will be? The maximum annual temperature range occurs in continental interiors. So, continental interiors always there will be a maximum. Either it may be a hot condition or it may be a cold condition. It will be a maximum because of interior in nature. The equatorial region shows the minimum temperature range due to uniform heating. So, equator receives almost the uniform rays of sun. So, because of that there is a minimum temperature variation in equatorial region. The high temperature range is found in polar region because of oblique nature of rays and because of the contrastivity and because of cold nature. There is a vast difference in equatorial region and polar region. The area close to the ocean experience moderate temperature range, that we all know that the coastal region always experience the maritime climate, that is moderate climate. These patterns reveal the climatic extremes and control on the temperature. So, because of this it influences the climatic extremes, and then the control of temperature is happening because of all these processes. Global temperature gradient. So how globally the temperature gradient occurs? That is, the global temperature gradient is strongest in mid-latitude. Mid-latitudes, it is the temperate latitude, it is strongest, and it is relatively weak in tropical region. So in the lower latitudes it is relatively weak, and steep gradient occurs in the frontal zones. So the frontal, the border zones, it is very steep due to the mixing, and the gradient changes with the season, and it becomes stronger in winter. In winter season, how the gradient, temperature gradient will be there? It will be very strong in nature. The strong temperature gradient plays an important role in cyclone formation and development. So because of this strong gradient, what happens? The cyclone development, formation, so all these processes will happen. The next one is the tropical temperature distribution. That is, the temperature remains warm throughout the year. So in the tropical region, the temperature is warm throughout the year, and the horizontal temperature is very small. So horizontally the temperature will be very small, and the cloud cover, because of that the cloud cover will be very strong. The clouds will be strong in the tropical region, and because of that cloud cover, the temperature, it retains the temperature. So the daily temperature condition will be influenced by the cloud cover of tropical region. The maritime conditions dominate due to the surrounding ocean. So here you have the ocean, water is interrupting in the tropical region also. So it influences the coastal region climate. The intense convectional activity is common in this region. The convection, the heat air rises and cold air sinks. All this process is mainly happening in the tropical region, which adversely affect the temperature of tropical region. Mid-latitude temperature distribution, that is, this region shows a strong seasonal temperature differences. That is, horizontal temperature contrast the sharp and well defined. The horizontal temperature will be very sharp in mid-latitudes. The warm ocean currents influence eastern coastal regions. So wherever there is a eastern coastal region, it influences that is, the warm ocean current influences more in the eastern coastal regions. The continental interiors becomes very cold during winter. So the winter, the most important in the mid-latitude region. Overall, the temperature variability is very high. So there is not much contrast in the tropics, but here the contrast is very high in mid-latitude temperature distribution. Next one is polar temperature distribution. So these region records the coldest temperatures on the earth. So we know that polar region, it's very cold, extreme cold will be there. The extensive ice and snow creates this strong albedo effect. The reflectivity will be very high. The winters are marked with extremely low temperature, and ice extinct strongly controls the horizontal temperature distribution in the polar region. It very steep temperature gradients develop in the during the winter season. So this contrasticity will be there in the polar region. Next one is seasonal temperature shift. So there is a shift in the seasonal temperature. That is, global temperature belt shifts seasonally. So it is not permanent in one place, it shifts seasonally. So in the previous lecture we have seen, we have discussed about the 38-degree line, latitudinal line, there will be a shift. The same is here, that is, the seasonal shift will be there due to the apparent movement of sun. So when the sun is here, the temperature, the rays will be here. When the sun is moving up and down, north and south, there will be a adverse effect because of this apparent movement of sun. So they move northward. If the sun is moving northward, what happens during June, July, and the southward during December, January. So December, January, the southward the sun is moving. So this movement have the adverse effect in the seasonal temperature shift. This shift displaces the global pressure belts. So this is most important here, that is because of this movement that it displaces the global pressure belts. The changes in pressure belts modify prevailing wind system. So we have the prevailing winds. The prevailing wind system is also changing because of this apparent movement of sun. As a result, the wind directions vary seasonally. So the Coriolis effect also you can apply here. The deflection of these forces will lead to the change in direction of the wind. The anomalies in the temperature distribution, that is the urban heat island, due to what? That is increased local temperature. If there is increase in local temperature, it leads to the urban heat island. The El Nino and La Nina creates the global temperature anomalies. So we are experiencing that, and ocean and atmosphere interactions influence the climate. So we have discussed a lot in previous lectures about the ocean and then the atmospheric influence. So that plays a vital role. And the Arctic amplification causes the rapid polar warming. So polar is warming because polar region is warming because of the amplification of Arctic regions. The desert experiences extremely heat due to dryness and clear skies. Due to dryness and clear sky, the desert experiences the extreme climates. So you can very well correlate with the effect of the Arab countries. So now what they are experiencing, severe cold. These are all the effects, adverse effect of the these processes, like the temperature distribution. There is anomalies in the temperature distribution. Because of that, the desert is changing into the cold region, and the coastal region is experiencing adverse effect of temperature. The temperature distribution data sources. The data source of temperature distribution have been collected by various methods. They are satellites. By satellites, we are collecting the continuous global temperature coverage is done with the help of satellites, and weather station which records the long term surface temperature data, and with the help of remote sensing technology which measures land, ocean, atmospheric temperatures, and global climate models. We are using models to analyze and simulate temperature distribution. And we have the ocean buoys, and which collects the sea surface and subsurface temperature data. So these data have been collected with the help of the methods, like various technologies and methods which we are using to collect the temperature distribution. The importance of horizontal temperature studies. So why it is so important? That is, it helps to identify and analyze the climatic zones. Each and every climatic zones is analyzed with the help of horizontal distribution of temperature, and it determines the global pressure belts and wind pattern. So it have a strong influence of pressure belts, wind patterns. So in such a way, this horizontal temperature studies is most important. It strongly influences the monsoon circulation and behavior. So the horizontal temperature plays a vital role in the monsoon circulation and behavior. It is important for the agriculture planning and land use planning and making decisions. So this horizontal temperature studies will guide how to plan agriculture, and how to use the land efficiently will be done with the help of these studies. It provides basis for an accurate weather forecasting. So these are all the importance of horizontal temperature studies. To sum up with the entire lecture, the horizontal temperature distribution refers to how temperature varies across the different regions of the earth, and temperature is influenced by factors such as latitudes, altitudes, proximity to ocean or current, that is continents, nature of land and water, cloud cover, ocean currents, and prevailing winds. The data have been collected with various methods by meteorological stations, satellite, remote sensing, and global climate data sets. It is most important for climate analysis, weather forecasting, agriculture, and energy planning. So I hope and you have understand the basic concept of horizontal temperature distribution. In the upcoming lecture, we will be discussing on the vertical temperature distribution. Thank you.